Okay, so as we saw on the last unit, a limit helps us find a value of a graph even if it's not necessarily the same on both sides, or there may be a hole in the graph, but we can still find the value the graph would intend to be at, and that's going to be really important when we move on in calculus. Okay, so we're just going to talk about multiple limits together, and your objective is still the same: determine the limit of functions algebraically and graphically. And when you look at the properties of limits and their rules, you're going to see that you may have two functions, f of x and g of x, and those will be put together. So those are like two different functions, and you'll see an example below to help you with that. Okay, so first of all, the sum and difference rule, and these follow exponent rules and log rules very closely. So the limit of, as x approaches c of f of x plus g of x is the same thing as just taking the limits separately and adding them together. Same thing if there was a minus in between. It would be the same thing as kind of like distributing that limit and finding them separately. Okay? Now your product rule is the same kind of idea, but multiplying between. The limit as x approaches c of f of x times g of x is the same thing as if you distributed and just multiplied at the end. So is equal to the limit as x approaches c of f of x times the limit as x approaches c of g of x. Okay, now the constant rule may be something new. The limit as x approaches c of k, that's another constant, times f of x is the same thing as if you just took k out front and then timesed it by your limit. Okay, let me erase that, but that is what's happening here. So it'd be the same thing as pulling your constant out front and then finding the limit and multiplying them together at the end. Okay, and the quotient rule is kind of like the other rules where you're just distributing the limit to both and then dividing at the end. Okay, so let's use those rules in an example that's very straightforward. So if you look at example 1, sorry, it's kind of blurry when I zoom in, but your paper shouldn't be blurry. So use a given information to evaluate each limit given that the limit as x approaches 5 of f of x is 3, and the limit as x approaches 5 of g of x is 6. So notice they're approaching the same constant. That's important. They're both approaching the same value for x. Okay, and then we're just going to follow the rules. Follow the rules right above. Okay, so if you look at number 1, try to figure out what rule that would be, what it looks most like. Okay, and this one looks like the constant multiple rule. So you have the limit as x approaches 5 of negative 2 times g of x. I'm going to have to cross this part out for now. Hopefully your paper didn't print that way. But let's just do number 1 right below it. Okay, so this will be the same as pulling negative 2 because it's a constant out and then taking the limit as x approaches 5 of g of x. Okay, so that is your constant multiple rule. And since we are given that the limit as x approaches 5 of g of x is 6, this is just negative 2 times 6, which is negative 12. That's number 1. Okay, so number 2, we're going to look at what rule here. That's your sum and difference rule. Okay, so we can take the limit as x approaches 5 of each of the functions separately and just add them together at the end. So this is equivalent to limit as x approaches 5 of f of x plus limit as x approaches 5 of g of x. Okay, for number 2. Alright, and those are both given to us. So we have 3 plus 6, and that will give us 9 for number 2. Okay, so this is just a very simplified way of expanding the rules so you understand them. Of course, you're not always just going to have a value for your function. You may actually have to plug it in to a real function. Okay, so I'm going to erase what I have here, and then we'll do 3 and 4. Alright, number 3, that's going to be your quotient rule. So it's the same thing as limit as x approaches 5 of f of x all over lim as x approaches 5 of g of x, which is 3 over 6, and that's 1/2. Okay.